Good day and welcome to AFD'S Academy. I'm the instructor, Arthur Francis Tibam. Today, I want to solve the question which I gave us an assignment on the percentage of water of crystallization. I've seen a whole lot of answers being given, which I must commend all of you for a positive work well done, because it shows that you are committed to the cause of answering those questions. I have to ensure that the needful is done. I have to answer the question for us so that we see in case of necessity. So I will read the question again, then I will bring out my given, then solve it. Okay? We said that 2.86 grams of washing soda were dissolved in 100 cm cube of water. 12.15 cm cube of this solution neutralized in 24.50 cm cube of 0.1 mole per dm cube hydrochloric acid. All right, we should calculate the molar concentration of the base, the number of moles of water of crystallization, and the percentage of water of crystallization. So let me state out the given before we proceed with anything. Okay. So from the given, I have the acid and the base. So A here is for the acid, which is HCl, and B is the base, which is sodium triiodocarbonyl-4.XHO2 is hydrated. We say 2.86 grams of the washing soda, so I have the GDMQ is 2.86 gram in 100 cm cube. I'm going to explain that. Then 12.15 of this solution neutralized 24 of the acid. So the volume of the base is 12. So we have VB is 12.15 cm cube. This neutralized 24, the acid, volume of acid is 24.50, okay, 24.5, yeah, cm cube. And the volume, the molar concentration, the concentration of the acid is given to be 0.1 mole per dm cube. We should calculate the molar concentration and so on. So from here, we are first of all going to balance our equation. So we'll be able to get the number of moles of acid and the number of moles of the base. So the acid here is HCl plus Na2CO3 dot X water. Normally, we're going to have sodium chloride plus CO2 plus water, then plus X water. So we just need to check to see how, if it is balanced. We have 2 sodium, and I have 1 hydrogen here plus 2. So here I have 2, 2, 4. So hydrogen is not balanced. If I add 2 here, hydrogen is balanced. So by virtue of that, I will have 2 here. So I have 2 chlorine, 2 sodium, 2 sodium. Carbon is 1, CO2. Okay, everything is balanced. So from here, number of moles of acid, Na, is 2, and the number of moles of the base is 1. Okay, if we've gotten this, remember I said I'm going to explain this. I said they gave us 2.86 gram in 100 cm cube. We should know that those are the values for the mass concentration. Most times, or most of us may not understand what the 100 meant. We remember the formula for mass concentration to be mass over volume, but the volume must be in dm cube. So by virtue of that, I am going to convert this mass concentration of the hydrated into a complete variable, which is 2.86 over 100 divided by 1000 in dm cube, which is 2.86 divided by 0.1. That's 28.6. So I have 28.6 GDM cubed. So that is the mass concentration of the hydrated. So the first thing we do is to convert the gram and the volume into its standard value, which is the GDM cube. So this becomes the mass concentration of the hydrated. Remember, we're also going to get the mass concentration of the anhydrous. I don't think they asked us, but we should know. But first thing first, what did they want us to do? They said we should calculate the first thing, the molar concentration of the base. We have the molar concentration of the acid, which is Ca. That of the base is not given. So the first thing we do, we use the formula, the CAVA, to get that. So let's begin. Number 1. Molar count of B can be gotten using the formula CAVA over CBVB equals to NA over NB. And I'm looking for CB, so my CB will be equals to CAVA-NB over VB-NA. And this is equals to Ca is given to be 0.1 mole per dm³ times volume of the acid is given 24.5 cm³ times number of moles of the base is 1 all over volume of the base is 12.15 cm³ times number of moles of the acid is 2. So and this will give me, so I have 0.1 times 24.5 divided by 12.15, so divide by 2. So 0.101. So this is 0.101 approximately mole per dm³. So I've gotten the concentration of the base. So let me put it here. Cb is equal to 0.101 mole per dm³. So the next thing is the number of moles of water of crystallization. For me to get the number of moles of water of crystallization, I must have to get the mass concentration of the anhydrous. And how am I going to do that? I have to use the molar count times the relative molecular mass of this, which is the anhydrous. Remember, I've told us earlier on that in this calculation, the mass concentration of the anhydrous must be lower than that of the hydrated. Anytime you do your calculations and that of the hydrated is anhydrous is bigger or larger than that of the hydrated, then you're wrong. That of anhydrous should be lower at all times. So this is what we have. Let's find out the mass concentration of the anhydrous. That is only when we can apply to check the number of moles of water of crystallization. So now, that of hydrated is 28.6. That of anhydrous is what? Let's find out. Alright, although that wasn't required, they didn't ask us, but it is a prerequisite of what we must do. If we do not do that, we cannot proceed further, so we should know that. So I move on to say the mass count of anhydrous B is equal to molar count of B times relative molecular mass of anhydrous B. And this is, the molar count is 0.101 mole per dm³. We multiply that by the relative molecular mass of this is 106. 23 times 2 plus carbon is 12 plus 16 times 3, which is 48. That gives us 106 G mole. So in that case, I will be having my 0.101 times 106 will give me 10.706. So this is 10.706. So if I want to take three significant figures, I can take 10.7. So I can leave it there. So this is the mass form GDNQ. So comparatively, we have seen that the mass form of the anhydrous is lower than that of the hydrated. So from here, we know that we are on track, we're doing the right thing. So finally, we have to check what is it then, the number of moles of water of crystallization. Then we have to apply our formulas, which says that the number of moles of water of crystallization is the mass concentration of the hydrated over its relative molecular mass equals to the mass count of the anhydrous over its relative molecular mass. So I've gotten this, so let me put this here. GDNQ of anhydrous B. Hydrous B is equals to 10.7. Let me just use all of it. It doesn't matter, but we deal with three significant. I'll do that in my final answer. So let me proceed now. I can take this out. So now, how then do we proceed? We say number of moles of water of crystallization. The number of moles of water of crystallization will become the mass count of the hydrated, which is 28.6, over the relative molecular mass of the hydrated, which is 106 plus X18. Is equals to the mass count of the anhydrous, which is 10.706, over the relative molecular mass, which is 106. I have to make X the subject. So I do my cross multiplication. I will have 10.706, open bracket, 106 plus X18 is equals to 28.6 times 106. Okay, now we move. From here, I will expand by 10.706 times 106 is 1134.836 plus 706 times 18, 192.708x. Remember there's x there. This is equals to 28.6 times 106 is 3031.6. So making this the subject, x will become 3031.6 minus 1134.836 over 192.708. All of that is equal to what? So let's see the number of moles. So now I have this minus 1134.836 equals to this, divide by 192.708, 9.8. 9.8 approximately 10. So our number of moles of water of crystallization is 10 moles. So that definitely is a decahydrate. So if I have this compound now, Na2CO3.10H2O. So I will say this is sodium triazocarbonate 4 decahydrate. That is the complete name. So if that is true, that which we've gotten right now, we should calculate the percentage. We will know officially that the percentage of water crystallization will be very high. Will be above 70, if not mistaken, because we got 10 moles. So let us implement that to get the percentage of water crystallization now. So for lastly, the percentage of water crystallization is equals to, we have our X water over the compound Na2CO3.X water times 100. The X now we're having is 1018. The relative molecular mass of water is 18 over 106 plus 1018 times 100. And that is equals to what? So we go 10 times 18 is 180. All right, 180 plus 106 is 286. So we have 286. So let's begin. 180 down. I have 180 divided by 286 times 100. Oh, 62.9. All right, 62.9%. So this is the percentage of water crystallization. So in the question which I gave us, I requested for the molar concentration of the base, which is 0.101. That was our first answer. The second answer was to know the number of moles of water of crystallization is 10. From my calculation is 10. And finally, the third one is the percentage of water of crystallization, which is 62.9. These are the three answers. So you have to correspond or check what you have solved so far with these and see if you are right or wrong. Most of you, I saw your answers. The reason you made those mistakes were because you never converted this into the mass concentration of the hydrated. You got confused along the way, so I will encourage you to look carefully or follow through carefully what I have just done here so that you'll be able to balance yourself and not make mistakes when the time comes. So this is it. Thank you. I really appreciate it. Thank you.